Okay, so we're going to talk about Module 3, Lesson 1 today. This is an introduction to fractions and mixed numbers. So before we get into that too far, we want to talk about some of the terms we'll be working with throughout this lesson. We look at a fraction like this, for example. Okay, there's a couple of pieces that make up the fraction. The top number, the 3 in this case, is called the numerator. Okay, and then that bottom number, the 5, down below is called the denominator. Okay, and then the little bar in the middle here is called the fraction bar. Okay, and this fraction is an example of what's called a proper fraction. Okay, proper fractions have numerators that are less than the denominators. So the reason why this is a proper fraction is because the 3 up top is less than the 5 on the bottom. So some other examples of proper fractions would be 2/3 is a proper fraction because 2 is less than 3. My numerator is less than my denominator. 12/13 is a proper fraction because 12 is less than 13. Anytime we have a fraction where the top is less than the bottom, we're looking at a proper fraction. Okay, we can have a fraction like this, 7/6. Again, numerator 7, denominator 6, but this is an example of an improper fraction. Okay, and we know that this is improper because the numerator is greater than or equal to the denominator. 7 on the top, bigger than 6 on the bottom. So some other examples of improper fractions would be like 10/3. 10 on the top, bigger than 3 on the bottom. And 5/5 is an example of an improper fraction because any fraction is improper when the numerator is greater than or equal to the denominator. Now, don't let the term improper mess you up. It sounds like maybe we're doing something wrong to use improper fractions. We are not. It's fine to use improper fractions, and in fact, a lot of times, especially if you're doing math by hand, it's easier to work with improper fractions. So we'll definitely be seeing those and working with them as we go through the rest of the course. The last big kind of fraction that we're going to be dealing with in this lesson is a mixed number. We could have something like 11 1/2 is how we read this. Again, it's called a mixed number, made up of a couple of pieces here. Okay, we've got the whole number part of our mixed number, which is the 11, and then we have this extra fraction part that goes on. Basically what this is we're going to go out to 11, and then we're just going to go a little half unit further. Okay, and we'll look at those a little more later. Okay, we use fractions to represent parts of whole objects. It's one of the most common ways that we use fractions here. So if I look at a shape like this circle that I've divided into 4 parts here, and we do need to assume that these parts are all the same size, ignore the fact that my drawing is not perfect. This really only works if all my pieces are the same size, okay? I'm going to make a fraction out of this, and I'm going to start by looking at the whole shape and asking myself how many pieces did it take to make up the whole shape? Well, there's a total of 4 pieces here, and so that's going to be my denominator value. The denominator for this setup is the total number of pieces it takes to make one whole object. And then the top is going to be the number of pieces that we're interested in. And so let's do a fraction for the number of shaded pieces for a shape like this. Well, how many shaded pieces do we have? Well, we have 3 shaded pieces, so our numerator is going to be 3. And our denominator is still 4. So 3/4 is a fraction that represents the shaded part of this particular shape. Okay, we could do a fraction for the unshaded parts. Okay, how many pieces are there total in this? Well, there's 4 total. So our denominator is 4. And then my numerator is going to be the number of unshaded pieces that I have. Well, there's just this one piece over here that's not shaded. And so my numerator is just going to be 1. So that's going to be the fraction that represents the unshaded part of this particular circle. Okay, so for this example, we're going to do kind of the same thing, except for now I've got a couple of different separate shapes here. So we're going to actually write an expression for a fraction for this example, and then we're going to also write a mixed number for this as well. Okay, so we're going to start the same way. If I'm just going to try to write a fraction for this thing, then my denominator is going to be the number of pieces it takes to make one whole object. Well, if I'm just looking at one of these squares, or one of these rectangles, it takes 4 pieces to make one of these rectangles, right? So my denominator is still going to be 4. It's the number of pieces it takes to make one object, okay? And then if I'm writing a fraction for the shaded portion of this, my numerator is going to be how many shaded pieces do I have? Well, I have 1, 2, 3, 4, 5 total shaded pieces. So 5/4 is going to be my improper fraction that represents the shaded part of this picture. And you'll notice I have more than one whole object. Like over here, this is one whole complete filled in rectangle, right? And then I have some extra over here on this side. Now, improper fractions represent values that are bigger than 1. So it makes sense that for this particular picture, I have an improper fraction because I got more than one whole thing filled in. Okay, I do have another way that I could write this. I can write this as a mixed number as well. I'm going to start with the whole number part. Well, to fill in the whole number part, I'm just going to look at how many whole complete rectangles do I have. And this is a whole complete rectangle. So I have one whole complete rectangle. This is not a complete rectangle. So what I'm going to do over here is I'm going to write a fraction for just that second piece. Okay, well, that second piece, I have 4 pieces that make up my entire rectangle, and then one of them is shaded. So 5/4 and 1 1/4 are equal value. Okay, we can use them kind of interchangeably. Okay, so now it's important to remember that fractions are just another way to write a division. So if we have something like 5/5, this is an improper fraction. We talked about how the numerator greater than or equal to the denominator gives us an improper fraction. But we can also just divide the top by the bottom. We talked about that back when we were doing order of operations stuff in Module 1. So this is the same thing as 5 divided by 5, which is equal to 1, right? We can do the same thing with like 10/10. 10/10 is equal to 1, or 20/20. 20 divided by 20 is equal to 1. In fact, any fraction where we have the same value on the top and bottom is always going to be equal to 1. And this is something we'll see later, something that's useful to us going forward. Okay. Okay, so we're going to ask you to graph some fractions on a number line. And this is not as hard as it looks like. The first thing you got to notice here is my denominator of my fraction is 3. And if you look up here, we have 1, 2, 3 little chunks that make up the region from 0 to 1. So again, that makes sense with what we've been talking about with the denominator. The denominator is the number of pieces it takes to make an object. So in this case, it takes 3 pieces to make an object here because our denominator is equal to 3. And so if we want to graph 2/3, we're going to start over here on the 1, and we're going to count from there. So 1, counting the tick marks, 2, 3. This one right here is 2/3, and this is where we're going to put our dot. Like in the MyMathLab program, it's going to have you take a dot, click on it, and then drag it to where it's supposed to go. If you wanted to grab it and take it over to that second tick mark, that's where you want it. Okay? Similarly, we could ask you to graph 4/3. Okay, this is now an improper fraction. We just talked about how improper fractions represent values that are bigger than 1. So if I'm doing kind of the same thing, get some of this out of the way. Want to look for where this is going to be. I'm going to start over here on the left. I'm going to count 1, 2, 3, 4 pieces over. So right over here is where 4/3 is going to be. And you'll notice that that is bigger than 1. We're past 1 on our number line. So makes sense. Improper fractions should have values bigger than 1. This one's to the right of 1 on our number line. Okay, next we're going to talk about how to change mixed numbers to improper fractions and back. Okay, and this is one where you'll have to do a little multiplication division by hand. Calculator is not the most useful thing in the world, so this is something you might have to practice on a little bit. Let's start with something like 5 over 3. We want to change this into a mixed number. Okay, so what we're going to do here is we're going to take the top and we're going to divide it by the bottom. So 5 divided by 3, if you put this in your calculator, you're going to get a bunch of decimals. We don't really want decimals so much for a problem like this since we're working mostly with fractions. So not the most useful thing in the world, but if we do it by hand, it's not too bad. 3 goes into 5 one time. 1 times 3 is 3. And then we subtract is what we do when we're doing kind of this old-fashioned long division. So 5 minus 3 is 2. So this number up top, we call this the quotient, is going to be our whole number. Our remainder down here is going to go up top. And then our denominator is just, it's not going to change in this process. It was a 3 over here. It's still going to be a 3 afterwards. So 5/3 is equivalent to 1 2/3. I just divided the top by the bottom and then put it together. Whole number goes there, remainder goes there, and then my denominator just stays the same. So let's do one more. Let's say we have something like 11 over 5. We're going to do the same thing. We're going to divide the top by the bottom. So 5 goes into 11 2 times, since 2 times 5 is 10. That's the closest we can get without going over. 11 minus 10 is 1. Okay, so this 2, our whole number. Okay, our remainder of 1 is going to go up top, and then our denominator is going to stay the same. It was a 5 before, it's going to be a 5 after. So 11/5 is the same as 2 1/5. We've changed our improper fraction into a mixed number. Okay, now we can go the other way. Say we have something like 6 1/3. We want to take that, we want to change it into an improper fraction. Okay, what we're going to do is we're going to take our denominator, we're going to multiply it times our whole number, and then we're going to add our numerator to that. So 6 times 3 plus 1. Kind of think of it as going around like that. Okay, and then our denominator is never going to change. So our denominator was 3 here. It's still going to be 3 here. And then we're just going to work this out with the order of operations. 3 times 6 is 18. 18 plus 1 is 19. 19 over 3 is our improper fraction there. Let's do one more. Say we have 5 4/5. We want to change that into an improper fraction. We're going to multiply over here, and then we're going to add up here. So 5 times 5 plus 4, and then our denominator just doesn't change. It's still going to be a 5. So 25 plus 4 is 29. And there is our equivalent improper fraction that we're looking for. Okay, so next let's look at a few kind of special cases of these division things that we want to be very comfortable with because they do come up pretty often. Like when we have a fraction with a 1 on the bottom, remember this just means 15 divided by 1. And when we divide something by 1, it doesn't change the value of our numerator. So 15 divided by 1 is just 15. We can just kind of drop that off. Similarly, 0 over 5. 0 divided by 5, well, 0 divided by anything is always going to be 0. It's like if I have no money and 5 people want to borrow money from me, everybody's getting $0, right? So 0 divided by 5 is going to be 0, right? The last example down here, when we have 7 divided by 0, this is like I have $7. I want to divide it 0 ways. It doesn't make any sense with the way that we use math. So we just can't do this. You can't divide by 0. You can't have a 0 on the bottom. We say that this is undefined. It doesn't make any sense with the way that we do math. So Zeros on the top are fine. 0 divided by anything is equal to 0. Zeros on the bottom are not fine. You can't divide by 0. So we say that that's undefined. Okay, so next we're going to talk about this idea called prime factorization. Prime factorization is where we take a number and we break it down into a multiplication of numbers that are all prime. Basically, we're going to break this thing down as far as we can. And so the way that I'm going to do this, I'm going to use a method called the tree branch method. There's plenty of other methods to use prime factorization. I don't really care what you use. So if you got something that works better for you, go for it. But for me, what I'm going to do is I'm just going to take this and I'm going to put a couple of tree branches off it. And I'm just going to think about what are a couple of numbers that I can multiply together to get myself 40. And the nice thing here is you can't pick wrong. You can start with any pair. You can start with 2 times 10 or 2 times 20. You could start with 4 times 10. You can start with 8 times 5. Doesn't really matter which of those you start with. Any of them are fine. I'm just going to start with 4 times 10. Okay, and then what I'm going to do is I'm going to see if I can break these things down more. Now, you never want to put a 1 in here because 1 times anything, 1 can be a factor for anything. It doesn't really help us at all. But we can break these down some more. So 4 is 2 times 2, right? 10 is 2 times 5. Okay, then I want to try to go further, but I'm just not going to be able to. The only way that I can make 2 with multiplication with whole numbers is 2 times 1, right? So 2 is a prime number, so I'm done here. And then this 2, the same thing. This 2, the same thing. 5, similarly, is only 5 times 1. It's the only way to make 5 with multiplication. So 5 is prime as well, and I am done. So 40 is equal to 2 times 2 times 2 times 5. All those numbers are prime. So this is called my prime factorization of 40. Okay, something that's going to be useful to us for a few things as we go through the rest of the course. But let's practice that one more time before we start to show why we care about prime factorization when we're talking about fractions. Let's do 72. Let's do a prime factorization of 72. So what I'm going to do first off is I'm going to take this, I'm going to break it down using any pair that we want. I'm just going to use 8 times 9. Okay, and then we're going to break that down some more. So 8 we can definitely break down into 2 times 4. And 9 we could break down to 3 times 3. Okay, this 2, I can't break it down anymore. It's already prime, but I can break this 4 down some more. Now, one thing that I would recommend is go ahead and bring this 2 down. It seems like a little silly maybe, but I've seen so many people that lose these as they're going on down if they don't bring them all down the same number of steps. Okay, so my prime factorization of 72 is 2 times 2 times 2 times 3 times 3. Okay, now just a little, you don't have to do this for this class. This is fine, 2 times 2 times 2 times 3 times 3. But we've seen in the past how when we have the same factor repeated multiple times, we can use an exponent to rewrite that if you want. So if you'd like to, 2 times 2 times 2 is fine, but you can also write that as 2 to the third. Okay, and then 3 times 3 is the same as 3 squared. So we would actually take either one of these answers. But in the future, it's handy to kind of be able to do both. Okay, so why do I care about prime factorization? Well, I care about prime factorization because it's going to help me simplify my fractions down to lowest terms. Now, fractions can be written in many different forms that are equivalent, equal values, right? But math is complicated enough where we want to make it as simple as we can to interpret our answers. We want to be able to figure out what the simplest form is for our answers. So we're going to do that with prime factorization to help us out. So if I have a problem like 12 over 20, I'll tell you right now, this is not in its simplest form. We're going to be able to write a fraction that is simpler out of this, and we're going to use those prime factorizations to help us. I'm going to start with this 12, and I'm going to break it down. Well, 12 is 2 times 6. and 6 is 2 times 3. That 2 is prime, so I can bring it on down. So 12 is like 2 times 2 times 3. Similarly, I can do the 20 on the bottom. So 20 is 2 times 10, and 10 is 2 times 5. And so my prime factorization of 20 is 2 times 2 times 5. So if I break it down like this, I can think of that 12 on the top as being 2 times 2 times 3, and that 20 on the bottom as being 2 times 2 times 5. And then what I can do next is I can look for common factors on the top and bottom. Like here, I've got a 2 on the top, I've got a 2 on the bottom. We know 2 divided by 2 is equal to 1. We can cancel those out. Okay, in the middle, I've got another pair of 2's that are going to cancel out. And 3 and 5, there's nothing I can do there. And I know that there's nothing I can do because those numbers are prime. I've done my prime factorization. They don't have anything in common, and so I can bring those on over. And so 12 over 20 over here that we started with is equivalent to 3 over 5 over here that I ended up with, but this 3 over 5 is much simpler, and that's what we're looking for when we're reducing fractions. We're looking for fractions that are in their simplest form. So if we do these prime factorizations, we cancel any common factors we have top to bottom, we'll get a new fraction at the end that's equivalent to what we started with that's in its simplest form. And that's something that we'll really want to do when we're going through this fraction work. Okay? So hopefully that's enough to get you off to a good start here in Module 3, Lesson 1. Please don't hesitate to let me know if you have any questions, and you'll have a good day.